Hello students, welcome to the class. In the last class, we started with motion in a plane chapter. So in a motion in a plane, we need to discuss few more points. Then after that, we can start with the multiple choice questions. Okay. So already in the last class, we discussed about properties of vector addition. So properties of vector addition, here we have the first property, that is vector addition is commutative. So this we saw already. What do you mean by commutative? That is a plus b is equal to b plus a. This is commutative. Then vector addition is associative. That is a plus b into bracket b plus c is equal to b plus into bracket c plus a or c plus into bracket a plus b. So this is what associative law, and vector addition is distributive also. That is m into bracket a plus b is equal to ma plus mb. This is what this is. These are the properties of vector addition. These are the properties of vector addition. Next. So next we have the resolution of a vector into rectangular components. So how can we resolve a vector into its components? Let us see that. If you consider a vector A with substance and angle theta. So here we can assume a figure like that is given by. So consider this as x-axis and consider this as y-axis. Suppose if I consider a velocity or the vector along this direction. So if I assume the vector along this direction, I can name this vector as A. Okay. So this vector can be resolved into two components. One is along x-axis and the other is along y-axis. So along x-axis, the component is taken as A cos theta. You can write it as AX also, so that it is understood that it is along the x-axis. And along y-axis, it can be written as AY sine theta. So a vector can be resolved into two components, into ax and ay, or into x component and into y component. Right, along x, the component is written as a cos theta, and along y, the component is written as a sine theta. So the magnitude of this vector is given by, that is under root of ax square plus ay square is what? It is the magnitude of this vector A. It is given by the magnitude of vector A. So this vector A is making an angle theta here. It is making an angle theta with the x-axis. Then its direction is given by, that is tan theta is equal to, it is AY divided by AX. It is given by tan theta is equal to AY divided by AX. This is called as what? The direction of the vector. Okay, so direction of cosine of a vector. If any vector A subtends an angle alpha, beta and gamma along x and y and z axis. Means suppose if you take a vector which is making an angle alpha, beta, gamma with x, y and z axis respectively, and its components along these axes are. So the components along these axes are taken as ax, ay and az. Then cos alpha is given by ax divided by a. Means how we are taking that. Suppose this is a vector a and here this is making an angle alpha. So I can join this one and this is your ax. So here we write cos alpha is equal to what? It is ax divided by a. Similarly, we can write for cos beta also, it is given by ay by a, and for cos gamma it is az divided by a. And we have one more relation, that is cos 2 alpha plus cos 2 beta plus 2 gamma is equal to 1. So this is the relation which you can derive it by using the trigonometric identity. Okay, so I hope this is clear to you. That is how can we resolve a vector into its components. Next, subtraction of vectors. How can we subtract n vectors? Let us see that. So subtraction of a vector b from a vector a is defined as the addition of vector b to vector a. So here we can define the subtraction of vectors as what? Subtraction of vector A, sorry, subtraction of vector B from A can be written as, that is A minus B, which is equal to, we can also write it as A plus into bracket minus B. So this is what subtraction of vectors formula. A minus B is equal to A plus into bracket minus B. Means whatever the B vector is there, you can take it in the bracket and you can simplify this. Then next we have multiplication of a vector. So multiplication of a vector, it is nothing but multiplying one vector into another vector or multiplying vector into a real number. See, the first law is, by a real number, when a vector A is multiplied by a real number n. So when a vector A is multiplied by a real number n, then its magnitude becomes n times, but the direction and the unit remains unchanged. So here what happens? When a vector A is multiplied by a real number, when a vector A is multiplied by a real number n, then its magnitude becomes n times, but the direction and unit remains unchanged. The direction and unit remains what? Unchanged here. That is what? That is called as what? Vector multiplication. Okay. Means only magnitude will change to n times, but the direction and the unit remains same. For example, it's just one example I am giving you here. If you take a number, a real number, if I take 2, okay, just assume that a real number 2 here. If we take the 2 as real number, assume that x is one vector quantity. So when you multiply this real number with your vector, here only the magnitude will change. Here only the magnitude will change, the direction and the unit. For example, suppose this is force. So whatever the unit is multiplied by the number, here its unit will be what? It will be Newton only, the unit will not change. So this we should remember. When a vector is multiplied by a real number, dash will change and dash dash will remain constant. That is, magnitude will be changing, direction and unit remains unchanged. Okay, then next, by a scalar, when a vector A is multiplied by a scalar S, then its magnitude becomes S times, and unit is the product of units of A and S, but direction remains same as that of vector A. So here what happens, when a vector A is multiplied by a scalar S, then its magnitude becomes S times. Its magnitude becomes S times, and unit is the product of units of A and S, but direction remains same as that of vector A. Okay. Next we have scalar or dot product of two vectors. Scalar or dot product of two vectors. See here, the scalar product of two vectors is equal to the product of their magnitudes and the cosine of the smaller angle between them. So how we can take, that is the product of the scalar product of two vectors is equal to the product of their magnitudes and the cosine of the smaller angle between them. Suppose A and B are the two vectors, the product of their, means its resultant is given by what? The product of their magnitude and the cosine of the angle between them. Suppose if you take here, suppose if you take the two vectors, that is, one is A vector and the other one is B vector, assume that this is making an angle alpha here. Then here dot product is given by, that is, A dot B is equal to, it is magnitude of the two vectors is what? It is AB, and the cosine of the angle between them, it is given by cos of alpha. So this is how we represent the scalar or the dot product. That is, A dot B is equal to AB cos theta. Next, the scalar or dot product of two vectors is a scalar. So here let us see the properties of the scalar product. Scalar product is what? It is commutative. So what is commutative? That is, A dot B is equal to what? B dot A. This is the first property of the scalar product. Then scalar product is what? It is distributive. Distributive in the sense it is A plus B. A into B plus C is equal to A into B plus A into C. Okay. Next, scalar product of two perpendicular vectors is 0. So we take the scalar product of two perpendicular vector as what? 0. Then next. Means here what happens? The scalar product of two vectors when we take it as 0, when here they are perpendicular, they are saying. So when it is perpendicular, what happens to your alpha? The alpha value becomes 90 degree. So what is cos 90? Cos 90 is 0. Therefore, the scalar product between the two vectors when it is perpendicular, the answer is 0. Okay. Next, scalar product of two parallel vectors is equal to the product of their magnitude. Here, the scalar product of two parallel vectors means what happens here? Two parallel vectors in the sense when you take the two vectors, suppose they are parallel to each other. Suppose two vectors are parallel to each other. What is the angle between them? The angle between them is 0 degree. Therefore, it can be written as A dot B is equal to what? It is AB cos 0. A dot B is equal to AB cos 0. So, cos 0 value is 1. Therefore, it becomes what? It is AB. Okay. Then scalar product of a vector with the itself is equal to the square of its magnitude. Means if you take two vectors of equal magnitude, if the two vectors are having equal magnitude, then what happens here? That becomes A dot A is equal to, again they are parallel. Therefore, when they are parallel, the angle will be 0. Therefore, it becomes A dot A. Suppose if you assume that it is A dot A, when the angle is 0, then it becomes what? It is A square. So this can be defined as what? The scalar product of vector with itself is equal to the square of its magnitude, right? That is A square. Next, scalar product of orthogonal unit vectors. That is means you know already what do you mean by orthogonal unit vectors. Unit vectors means what? Whose magnitude is unity. That is called as what? Unit vector, right? So the scalar product of orthogonal unit vectors. Then next, so we discussed about cross product, sorry, dot product. Now let us discuss about the cross product. That is given by the vector product of two vectors is equal to the product of their magnitudes and the sine of the smaller angle between them. Means here what happens if you take two vectors. So when these two vectors are there, then the product of their magnitude is taken as. So in the dot product, what we did, we have taken it as A dot B is equal to AB cos theta. Here A cross B is equal to, it becomes AB sine theta. The direction of unit vector n can be obtained from right hand thumb rule. It can be obtained from what? Right hand thumb rule. Then next, if fingers of right hand are curled. So suppose if you the fingers of right hand, if you take it curled from A to B through smaller angle between them, the thumb will represent the direction of what? Here vector. The thumb will represent the, so you can do it, that is with your right hand, thus just curl the fingers. So whatever the direction of thumb is there, that is the direction of what? vector here. The vector or cross product of two vectors is also a vector. Okay, so this we need to remember. The cross product of two vectors is always a vector. Then next we have the properties of a vector product. So let us see the properties here. Vector product is not commutative. So scalar product is what? It is commutative, but vector products are not commutative here. That is A cross A dot B is not equal to B dot, sorry, A cross B is not equal to B cross A. This is what it becomes. A cross B is equal to minus B cross A. It becomes minus B cross A. That is what vector product is not commutative. The next we have vector product is what? It is distributive. Distributive in the sense we write it as A cross into bracket B plus C is equal to A cross B plus A cross C. The next vector product of two parallel vectors is 0. So the vector product of two parallel vectors we write it as what? 0. That is A cross B is equal to AB sine 0. So that becomes sine 0 is 0. Therefore it becomes 0. In case of scalar product, we have seen that when they are parallel vectors, the value is 1. When they are perpendicular vectors, the value is 0. Here it is reverse. Okay. Then next vector product of any vector with itself is again 0. So there it was a square, here it is 0. Then vector product of orthogonal unit vectors. Then next we have, that is vector product in Cartesian coordinates. So in case of Cartesian coordinates, the direction of vector cross product when C is equal to, where C is equal to A cross B, the direction of C is right angles to the plane containing the vectors A and B. The direction is determined by the right hand screw rule and right hand thumb rule. Right. So these are the properties of vector product. Then here we have the right hand screw rule. So what are the right hand screw rules? See here. The right hand screw rule states that a rotated right-handed screw from first vector towards the second vector. Okay. Then the direction in which the right-hand screw moves gives the direction of vector, and the right-hand thumb rule curl the fingers of your right hand from A to B. Then the direction of the erect thumb will point in the direction of A dot A cross B. So here right hand screw rule what it states. So suppose if you assume that you are tightening a screw, so that satisfies the right hand screw rule. In that case, the direction in which the right handed screw is moving, that gives the direction of your vector. And where the thumb is moving, that is the direction of A to B. So this is how we define the properties of vector product, scalar product, and right hand screw rule. Then this completes the synopsis of motion in a plane chapter. So let us discuss some numericals based on this chapter, right? So the first question is, right hand screw rule rotate a right handed screw from first vector towards second vector. Sorry, that is first question is, the equation of projectile is given by, y is equal to 16x minus 5x square divided by 4. The horizontal range is given by. So here the question is what? They have given one equation, that is y is equal to 16x minus, it is based on the projectile motion question, 16x minus 5x square divided by 4. The horizontal range is given by. So here the equation is that is the equation of trajectory motion is given by what? It is y is equal to, it is x tan theta minus gx square divided by 2 u square cos square theta. So this is equal to, we can write it as x tan theta into bracket. So into bracket, what I can write here? Into bracket, I can write it as 1 minus x divided by r. It can be written as 1 minus x divided by r, because we know already the formula for r, that is horizontal range. So by using that, we can simplify this equation as x minus tan theta, x into tan theta into bracket 1 minus x divided by r. So this is equal to, so x value is, the given equation is what it is, 16x minus 5x square divided by 4. This is what equation 1. This can be taken as equation 1. Then y is equal to, we can write it as 16x into bracket 1 minus, it can be written as x divided by 64 divided by 5. Okay, this is equation 2. Therefore, r is equal to 64 divided by 5. R is equal to 64 divided by 5, and the value of r is, by after calculation, we will get it as 12.8 meters. The value of r is taken as 12.8 meters. Okay, what we did here, whatever the given equation is there, they asked you to calculate horizontal range. So therefore, the equation of parabola, we need to take it in terms of horizontal range. That becomes x tan theta into bracket 1 minus x divided by r. Now we can rearrange the terms and we can simplify the given equation. Right? So only rearranging and simplification is important here. Next. Next question. A body of mass 2 kg has an initial velocity 3 meter per second. The value of u is given, the initial velocity along OE, and it is subjected to a force of 4 newtons of in OF direction perpendicular to OE. The distance of the body from O after 4 seconds will be. So we need to calculate distance of the body after 4 seconds. So they have given the figure here. So I'll draw the figure. That is, see here, the figure is like this. You can see along OE, it is initial velocity is 3 meter per second, and the force is applied 4 Newton along OF. You can see OF also. We need to calculate the distance of body from O after 4 seconds. So it is a projectile motion. So when it is a projectile motion, here we can take the equation of motion here. The equation of motion is given by, that is, see here, the body moves horizontally. So the body is moving along horizontal direction with a velocity of what? 3 meter per second. The velocity of what? 3 meter per second. Right. In the time interval, that is 4 seconds for horizontal motion. Right. Therefore, here, what we can write, the distance traveled is equal to velocity into time. So velocity is 3 into time is 4. That is given by 12 meter is what the distance, calculate the distance traveled here. And now in the vertical motion, what happens? It is traveling with a zero velocity. Therefore, here the equation becomes y is equal to, for vertical motion, the equation becomes y is equal to ut plus half at square, and that is equal to, as I said, vertical motion, the velocity is 0 plus 1 by 2 into a value. It is becoming u divided by 2. Sorry, 4 divided by 2. It is 4 divided by 2 into time. It is t square. It is 4 square is equal to. So here if you simplify this, that is 2 to 4, 4, 4 will get cancelled. So after that 4 square is what? 16 meter. 4 square is, it is 16 meter is what? Y value. Now the distance from O is given by, the distance from O, it is given by D is equal to, the distance from O is given by, it is D is equal to square root of x square plus y square. It is square root of x square plus y square, which is equal to x value is how much? It is 12 square plus y value is how much? It is 16 square. So 12 square plus 16 square. 12 square is 144 plus 16 square. Then after that, 16 square, that is 256. 256 plus 144. So if you do 256 plus 144, it is 270. So if you take the square root of 270, the answer is, means if you add both the values, it becomes 400. The square root of 400, it is 20 meters. It is 20 meter. Okay. Correct. Therefore, the correct option is option C. Option C is the correct option here. Then next question. A body starts from the origin with an acceleration of 6 meter per second square along the x-axis and 8 meter per second square along the y-axis. Its distance from the origin after 4 seconds will be. So here a body is moving with an acceleration of 6 meter per second square along the x-axis and 8 meter per second square along the y-axis. Its distance from the origin after 4 seconds will be. We need to get the distance after 4 seconds, right? So let us see the formula and the solution. That is given by, so we have y is equal to ux into t plus 1 by 2 at square, which is equal to 1 by 2 into 6 into 4 whole square, because time is given as 4, right? Acceleration is given as it starts from the rest, the initial velocity will be 0, right? So substitute all the values here. So after substituting, that is 1 by 2 into 6, that is 3 into 4 square. So 12 3 it is 48 meters, that is the value of y. Now this is what? This is along x-axis. This calculation is along what? Along x-axis, the displacement along x-axis. So let us calculate the displacement along y-axis, and it is given by y is equal to uy into t plus 1 by 2 ay, that is into t square. So now what happens? It is 1 by 2 into acceleration is 8 here, and the value of t is, it is 4 square. Therefore, if you simplify, 2 ones are 2 fours are, and 4 square, this becomes 64 meter. It becomes 64 meter. Therefore, the total distance traveled from the origin, it is given by total distance, yes, is equal to, it is x square plus y square. So x square value, x square is how much? It is 48 whole square plus y square value is how much? It is 64 whole square. 48 whole square plus 64 whole square. That is nothing but it is 80 meters. It is 80 meters, right? Yes is equal to 80 meter. That is option C is the correct option here. Option C is the correct option. Okay. Let us see the next question. In a projectile motion, velocity at maximum height is. So what is the velocity of the particle at the maximum height? Option A is u cos theta by 2. Option B is u cos theta. Option C is u sin theta by 2. Option D is none of these. See here, at the maximum height, the vertical component becomes 0. At the maximum height, the vertical component becomes what? 0 here. Therefore, it is given by V is equal to u cos theta plus u sin theta. V is equal to u cos theta plus u sin theta. This is equal to, I'll write it as u cos theta. Why? Because in a projectile motion at the maximum height, body possesses only horizontal component. At the maximum height, the body possesses only horizontal component of velocity. Therefore, the vertical velocity component becomes 0. Therefore, the correct option is what? U cos theta is the right option. U cos theta is the right option here. Therefore, option B is the correct option. Next question. A body is thrown at an angle of 30 degree to the horizontal with the velocity of 30 meter per second. After 1 second, its velocity will be, in meter per second we need to write. The value of g is given as what? 10 meter per second square. So it is thrown at an angle of 30 degree to the horizontal with the initial velocity of what? 30 meter per second. So after 1 second, its velocity will be, we need to calculate the velocity after 1 second. So let us see the solution. So here we have the formula. Velocity of projectile at any instant is given by, it is v is equal to square root of u square plus g square t square minus 2u gt sine theta. So the equation is what? Under root of u square plus g square t square minus 2u gt sine theta. This is equal to under root of, what is u value? U value is 30 whole square plus g value. G value is how much? It is 10, because in the question it is given as 10. Therefore, it is 10 square into bracket. T value is 1 square. Therefore, 1 square means time is 1 minus 2 u into g into t into sine 30. So sine 30 is how much? It is 1 by 2, right? Therefore, so now you can simplify this. Here, this is 30 into 10 is 300. 2 will get cancelled. So here it is 300 and here it is 10 square is 100. 30 square, it is 900. Right? So if you simplify this, it is root of 700. So this becomes root of 100 into 7. So square root of 100 is how much? It is 10. Therefore, it becomes what? 10 root 7 meter per second. The velocity becomes 10 root 7 meter per second. Therefore, the correct option is option A. Option A is the correct option, right? Let us see the next question. A projectile is fired at an angle of 30 degree to the horizontal. The vertical component of its velocity is 80 meter per second. Its time of flight is t. What will be the velocity of projectile when t is equal to t divided by 2? So what they are asking here, the question is, you need to calculate the velocity of the body. When the time of flight is t, the velocity is 80 meter per second. We need to calculate when the time is t by 2, half its value. Then what is the velocity? See here, as the components will be there, we cannot take it as directly t by 2 in the sense it becomes 40. No, it is not like that. Here we need to do the solution because as it is a projectile motion, the components will come. Okay, the initial velocity of projectile is given by the initial velocity of the projectile. I'll take it as uy is equal to vertical component they have specified. Therefore, it becomes uy is equal to u sine theta, which is equal to, it is 80. It is 80. Okay. Therefore, we can write u is equal to uy divided by sine of 30 degree because they have specified the value here. Uy value is how much? It is 80. 80 divided by, it is 1 by 2. That is nothing but 80 into 2. That is nothing but 160 meter per second. It is 160 meter per second. That is the value of uy here. At half of the value of time of flight, here the what happens here at that position, particle possesses horizontal component of velocity. So when we say that when the time is t by 2, the particle possesses the horizontal component of velocity. Therefore, it is given by ux is equal to u cos theta. That is equal to u value is how much? It is 160 into cos theta is what? Cos 30. Cos 30 is how much? It is root 3 divided by 2. So what happens here? That is 160 by 2. 160 by 2 is 80. Therefore, it becomes 80 root 3 meter per second. It is 80 root 3 meter per second. Okay. The correct option is option B. Option B is the correct option. Option B is the right option. Then let's see the next question now. That is, a particle P is projected with velocity u1 at an angle of 30 degree. Okay, so the angle is given as 30 degree with the horizontal. So here you can see in the figure also that initial velocity is making an angle theta with the x-axis. Another particle Q is thrown vertically upwards. You can see in the figure it is thrown vertically upwards with a velocity u2 from a point vertically below the highest point at of path P. Right. The necessary condition for the two particles to collide at the highest point is, so one is projected from P, one is projected from point Q with the different velocities. The P particle is making an angle 30 degree with the horizontal. The next, here both the bodies will meet here at a particular point. We need to calculate the velocity. That is given by both particle collide at the highest point. It means that the vertical distance traveled by both the particle will be equal. The vertical distance traveled by both the particle is equal. That is given by the vertical component of velocity is given by. So here we can take it as uv sine 30 degree is equal to u2. So this can be written as what? uv sine 30 degree is equal to u2, which is equal to u1 by 2. Why? Because sine 30 value is 1 by 2. So it becomes u1 by 2, which is equal to what? It is u2. Therefore, we can write it as u1 is equal to 2u2. u1 is equal to 2u2. That is option B is the correct option here. u1 is equal to 2u2. Option B is the correct value. Means when the velocity of P becomes twice of the velocity of Q, then both the bodies will meet at the highest point. So the condition is u1 is equal to minus 2u2. Let us see the next question. Next question is, a body is projected up a smooth inclined plane of length 20 root 2 with velocity u sorry, from the point M as shown in the figure. Okay, so figure I'll draw it. A body is projected up with a smooth inclined plane length 20 root 2 with velocity u from the point M as shown in the figure. The angle of inclination is given as what? 45 degree, and the top is connected to a well of diameter 40 meter. If the body just manages to cross the well, then what is the value of u here? We need to calculate the value of u. So let us do it. It is given by r is equal to, formula is r is equal to, it is u square sine 2 theta divided by g. So theta value is 45 degree, therefore it becomes 90, therefore the value of r becomes, it is u square by g. It becomes u square divided by g. Then next at point n. So first I will show you the figure, that is this is n, this is the velocity v, and here we take it as r. Okay, so here it is 40 meter, and then next here it is u1, and here we have ua from m to n. Okay, so the angle here, the angle is given, this angle is how much? It is 45 degree. This angle is 45 degrees. See the question, a body is projected up with a smooth inclined plane of length 20 root 2 with velocity u from the point M, which is shown in the figure. The angle of inclination is 45 degree at the top of, and it is connected to a well of diameter. So the diameter of the well is given as 40 meter. If the body is just manages to cross the well, what is the value of initial velocity? So range is equal to, we are getting it as the range is equal to u square sine 2 theta by g. That becomes u square by g. Here at the point n, the angle of projection of the body is 45 degree. That time if we consider the velocity as v, then if the body manages to cross the well, so here they have specified one condition that the body manages to cross the well, then here range is equal to diameter. Then it becomes range is equal to diameter. Then this condition is possible, that is the body will cross the well. That is range is equal to diameter of the well. So range is equal to, we have v square by g is equal to diameter. They have given 40. Therefore, I can write it as v square is equal to 40 into 10. 40 into 10 is how much? It is 400. So therefore, v becomes, it is 20. Therefore, v becomes 20 meter per second. As it is velocity, the value becomes 20 meter per second. Right? Option C is the correct option here. Let's see the next question. A projectile is fired with velocity u, which is making angle theta with the horizontal. What is the change in velocity when it is at the highest point. What is the change in velocity when it is at the highest point? So let us calculate. Since horizontal component of velocity remains always constant, was what they have given, it is making an angle theta with the horizontal. What is the change in velocity at the highest point we need to calculate? Here, the horizontal component of velocity remains constant. Only the vertical component of velocity will change. Okay, when it is a making angle theta and it is a projectile motion, the vertical component of velocity changes. So no need to solve it. We know that the vertical component of velocity is given by what? It is u sine theta. It is u sine theta. Therefore, option C is the right option. U sine theta, option C is the right option. Let us calculate the next one. That is, a body of mass 0.5 kg is projected. So a body of mass 0.5 kg is projected under the gravity with a speed of 98 meter per second at an angle of 30 degree with the horizontal. So mass is given as 0.5 kg under the gravity of speed of 98 meter per second and the angle is 30 degree. So what we need to calculate? We need to calculate the change in momentum. We need to calculate the change in momentum. See here, the change in momentum for the projectile motion is given by, change in momentum for projectile motion is given by, it is 2u sine theta, that is equal to 2 into u value is 0.5 into sine theta value is 30 degree. Therefore, here it becomes sine 30. Here they have specified that a body of mass, it is projected under the gravity. So when we are taking under the gravity, we need to multiply this quantity with what? That is g. Therefore, here it becomes 2 into 0.5 into sine 30 is 1 by 2 into it is 9.8. So 2 will get cancelled. Then 9.8 into 0.5. So how much is 9.8 into 0.5? So you may get the nearby value here, that is so 4.9 it is. So suppose if you take the acceleration due to gravity as 10, then it becomes what it is? 49. Okay, it becomes 49. Therefore, the option B is the correct option here. Option B is the correct option here. If you take G is equal to 10, you will get B is equal to 49. Let's see the next question. That is, a particle of mass 100 gram is fired with an velocity of 20 meter per second, making an angle 30 degree with the horizontal. When it rises to the highest point of its path, then the change in its momentum is, given by. Now here what happens? Momentum remains always constant. Okay, so change in for horizontal component, for vertical component the change in momentum is given by, for vertical component the change in momentum is given by, it is final vertical momentum. This is what change in momentum, final vertical momentum minus initial vertical momentum. So vertical momentum, final momentum is what? It is 0 because it rises to the highest point, means at highest point the velocity will be 0. Therefore, final momentum is 0 minus initial momentum. It becomes mu sine theta. It becomes mu sine theta. This is equal to, so mass is 100 grams. So 100 gram to kg is 0.1 kg into velocity is 20 into sine 30 degrees. So sine 30 degrees, how much? It is 1 by 2. So therefore 20 by 2 is 10. 10 into 0.1 is how much? It is 1 kg meter per second. 1 kg meter per second is the answer here. That is option D is the correct option. Option D is the correct option, right? Let us see the next question. Two equal masses are projected at the same height. Two equal masses are projected at the same height from 2 points. Okay, we can show in the figure according to the question. That is, so what they are saying here, two equal masses are projected at the same angle from the 2 points. You can consider two different points. So it is projected from here also and it is projected from here also. It is making an angle, same angle, that is angle theta. Both are having the mass m. Okay. By their range with equal velocity. The momentum at the point of their collision is. So momentum at the point of collision is given by. That is, here we can resolve it. Both the masses will collide at the highest point. So here at the highest point, the bomb bodies will collide of their trajectory with equal and opposite moment. So net momentum of the system will be, therefore what happens? The net momentum of the system will be what? It is 0. Why? Because at the highest point the final velocity is 0, therefore at this point the momentum becomes 0, right? Then the last question for today's class, that is, a particle of mass m is projected with velocity u. The particle is projected with velocity u here. Okay, then next, which is making an angle 45 degree, which is making an angle of 45 degree with the horizontal. The magnitude of the angular momentum of the particle about the point of projection when the particle is at its maximum height is. So here we need to calculate when the body is at highest point, what is the magnitude of the angular momentum. So let us see how to do this one. Once again. So here angular momentum is given by what? It is mv into r. Angular momentum is given by mv into r. At the highest point, the angular momentum can be written as mux into h. Therefore, L is equal to mu raised to q cos theta into sine square theta divided by mu cube into cos theta into sine square theta divided by 2 into g. It is divided by 2 into g. This is the formula for what? That is angular momentum for the projectile motion. Next, here by using this formula, we can substitute the values here. That is L is equal to m value. E is taken as m only and the velocity is taken as u. Therefore, it becomes u cube. And the angle is given as that is 45 degree. So when it is given as 45 degree, cos 45 is 1 by root 2. Sin 45 is also 1 by root 2. But it is sine square theta. Therefore, it becomes 1 by 2. So 1 by 2 into 1 by root 2. Right? Then numerator term is over. So if you want, we can write it 1 by 2 into 1 by root 2 divided by, it is 2 into g. So 2 into g I'll keep as it is. G also they have given it as only acceleration due to gravity. So if you see the options, we need to keep the terms as it is. No need to substitute any values. So simplify this. It becomes mv cube into 1 by 2 into 2 is what? It is 1 by 4. Right? Therefore it becomes 4 root 2 into g. So here that is m v cube divided by 4 root 2 divided by into g. So here actually option C is there, that is m, because see here option B and C, it is copied same. So that is correct option is what? M v cube divided by 4 root 2 into g. So you can take option C here, that option C and B, it is copied by mistakenly same. So correct option is m v cube divided by 4 root 2 into g, right? So we discussed in today's class related to trajectory motion and related to momentum and angular momentum for the projectile motion. In the next class, we'll discuss few more numericals. Okay, thank you.